So here we are at the pump lab. This one is going to be kind of hard to see. Essentially, the pump lab is a lot of manual labor, so you'll miss out on all that, all the joys of that. But basically, right now, this is the same Armfield hydraulics bench that we used in the Bernoulli lab and the orifice lab, but the outlet of the pump, instead of being attached to some sort of device like the orifice or the Bernoulli, is just attached to an outlet with a valve on it. We have a pressure gauge as well, right near the end that you can hopefully see in this shot, and that measures in meters of water. So these are pretty serious pumps in this lab. We'll get up to around 50 meters of water for the series configuration, which is over 150 feet. It's quite a lot of water head that these things can pump. So essentially what we're going to do is do the single pump configuration, which it already is set up for now. So right now, just the pump that's inside the hydraulics bench is connected only. And then we have a secondary external pump that we can connect both in series and parallel configurations. So we'll show you what that looks like when it's all set up. So in the pump lab, we're going to use what are called centrifugal pumps. And this is an example of one that I've taken apart to show you. So it's very similar, actually identical to the ones that we're going to be using in the lab. So the water will come in here at this central inlet and then be thrown out essentially out here. We can see how that works by taking the cover off. There we go. Very rusty. This is quite an old pump. So that central part was in here, and there's actually, it's sort of hard to see, but a very narrow gap once the water gets through this round hole, and it actually comes out these veins here. So a pretty narrow impeller. This is the impeller that spins. So essentially the water gets sucked in here and then gets thrown out the outside, and that's where the outlet was. And these impeller blades are shaped sort of in a curve like this, so that the water can get thrown out more efficiently. With the single pump, I'm going to show you this sort of interesting phenomenon that occurs when you close the valve and open the valve. It's going to be really loud for this whole pump lab, so I'm going to have to do voiceovers for all this, but hopefully it makes sense when I show you. Okay, so this is going to be an example of hysteresis. So you can see that right now the flow is in sort of a jet flow coming out really quickly in a small region, and we're going to have a transition point right there. So now Professor Benitz is going to start closing the valve, and we're going to see that it takes a lot longer, or it takes a lot more valve closing to get to that jet state. So it's still not jet, and there it is, the transition back. So basically the path at which you close the valve, if you're opening or closing, changes the behavior.
So what we're going to do is look at the parallel configuration right now, and so what we have here is the hose connected to the bottom of our lab bench reservoir. So the flow will travel through this hose into the center of that pump. It will be pumped out in a centrifugal fashion here, upwards into the top of our lab bench here. We have measurements on the lower pump so that we can see how much head that pump is pumping at, and then this is connecting from our lower pump. It's going to meet this path here, which is actually coming out of our secondary pump, which you can't see because it's hidden inside of our lab bench. Those two flows will come together. We'll be able to read the combined head here. It will flow out of this vessel which will go straight back into our reservoir, go back through each of the pumps, and come together. Now we've set up the series configuration, and so now what we have is 2 pumps in a row, which means first we're pumping from the pump that you can't see, the one that's inside the tank. It's going to travel down this tube and into the intake for our second external pump. The external pump will again pump it up through here and directly out of our faucet, leading that fluid to go back into our internal tank, where it will again go to the inner pump, then follow to the outer pump, and complete that cycle yet again.
Series. Fully closed series.